Oh, hello everybody. May the 4th be with you. Anyway, so one last little bit about conic stuff, and we'll probably get through this over the course of the next day, day and a half, is that one form we haven't talked about is what's called the general form of a conic equation. Now, general form of a conic equation looks something like this, where you'll have it written in descending order with your x squareds, your y squareds, and your x's and your y's and your constants and stuff like that. What happens with this is that we want to get it to look like one of our standard forms. We want it to look like one of our hyperbolas or an ellipse or a parabola. I am not going to go over any of the circle stuff because it's another day, day and a half of material that we don't really have time for, and they're really easy to work with. So what we want to do is look at the different types that we're going to work with. We're going to work with ellipses, hyperbolas, or parabolas. Now, one of the dead giveaways for parabolas, if you remember, is notice that you're only going to have one squared term if it's a parabola. If the y squared if the y value is squared, it goes left and right. If the x value is squared, it goes up and down. And that kind of gives you the idea. But here, since we have two values that are squared, that means it's going to either be an ellipse or it's going to be a hyperbola. Now, unknowingly what it is yet, we have to figure that out. So what happens is we have to set this thing up to do completing the square. Now, I know it's been a while since we've done that, but we'll go through a couple of quick steps here, and hopefully it won't be so bad. For example, first thing we want to do is I'm going to move the 2x squared over here, subtract the 4x. I know I have a plus a blank. Then I have a y squared. I don't have a y term, nor do I have another constant there, so I don't have to worry about anything here. But I do have to know that I'm going to move this constant over here, so it's a positive 4. Now, since I have a plus blank only in one spot, I only have to remember to put a plus blank once over here, because we're going to add things to both sides. Now, remember, the first rule of completing the square is that you have to have your first term, your a value, has to be equal to 1. So we have to factor out this 2. So I factor out the 2. I have an x squared minus 2x plus blank. The y squared is still here, so that's not going to be a big deal. But on the other side, since I factored a 2 out here, I have to remember that when I complete my square, I have to put something back in with this 2. All right? So this 2 keeps coming down. We have to turn this into a jump squared. Now remember, the rule was take half of b. So half of negative 2 is negative 1. Remember that negative 1 just drops right in here. The x goes here, and if I square negative 1, I get positive 1, and I add that to both sides of my equation. Now here is just a y squared, and on this side it's 4 plus 2, otherwise known as 6. Okay? Now, we can see that this is forcing us to probably think that it's going to be an ellipse. The reason why I'm thinking that it's an ellipse, because if you look at it, hyperbolas have the minus in between the two values. When you look at your ellipse, it's got the plus in between. So we have to get one side equal to 1, and in order to do that, we just have to divide everything by 6. In doing so, you'll get x minus 1 quantity squared over 3 plus y squared over 6 is 1. Now remember the rule for your a's and b's here. Excuse me. Our rules for a's and b's, it tells me that the 6 is bigger than 3, so that means 6 is my a squared term. So I know that this ellipse is stretched vertically, because that's what the picture shows me. Now, my center, basically I'm not going to have you guys graph these because there's just no way to do all that in one little formative sheet. So what we're going to do is we're going to do our center. Our center is at our h and k, 1 and 0. And then, I don't think our a squared term is 6, our b squared is 3, and then that means your c squared is going to be 6 minus 3, which is 3. So your a value will be plus or minus the square root of 6. Your b value will be plus or minus the square root of 3. And your c value will also be plus or minus the square root of 3. From there, it's a matter of, we know that we can add and subtract to get to our focus, our vertices, our co-vertices, and whatnot. So we know that our center is at 1 and 0, so our vertices are adding in and subtracting in the root 6's. So it's going to be, since this is going up and down, we just have to add that to the y value. So your vertices will be at 1 and then 0 plus the root 6, and then 1, 0 minus the root 6. This might look familiar from when we were writing equations given this information. It's kind of the same thing. You don't have to put the 0 here, but I'm just doing it to show you that you're adding it to both parts here. Your covertices, when you add your b value, this is 1 plus root 3, comma 0, 1 minus root 3, comma 0. And then your focus, remember focus always goes the same direction as the vertex, so it's 1 and then 0 plus the root 3, and 1, 0 minus the root 3. It seems like a lot of work for one quick problem, so we might not have to do so many of this stuff set up here. I might just have you guys just go ahead and get into the conic form and tell me what it is. All right, let's try another example. Okay, so same idea. 4x squared minus 9y squared plus 32x minus 144y minus 548 is 0. So same thing. We go ahead and we start grouping together our x's. So 44x squared, 32x, and minus 9y squared minus a 144y. And then I have to move the 548 to the other side. From there, I have to factor out my leading term coefficient. So I have a 4. I have an x squared plus 8x plus blank. Take out the negative 9, and I have y squared minus, excuse me, be plus 16y, because negative divided by negative is positive, plus blank is 548. Now, remember, I took out a 4 here, and I took out a negative 9, so I have to add those two back in. So I have plus 4 times whatever this part is, and I have a minus 9 times whatever this part is. Okay? Bring the 4 down. In parentheses, I take half of 8. Half of 8 is 4, so it's x plus 4. When I square that 4, I get a 16. So I take the 16 here and here. Keeping things balanced, put it on both sides of the equation sign, or equal sign, excuse me. Negative 9. Half of 16 is 8. When I square it, I get 64 here and here. Now, on this side then, let's go ahead and just type it all in. Let's see, we have 548 plus 4 times 16 minus 9 times 64, and I get 548. Okay. Now I have to set everything equal to 1. I have to set this side equal to 1, so that means I have to divide. Oops, I just realized I multiplied by 64, not 9 times 64, so scratch that. Sorry, I'm going to bring this back. Insert 9. 36. All right, never mind. So now I have a 36 over here, and then I divide everything by 36. Now, if you start getting really crazy numbers that you're dividing out, you're getting these god-awful fractions and stuff, that just tells you that you screwed something up here when you took out, you probably forgot to divide out the secondary term. You know, you took the 4 out, but you forgot to divide 32 by 4, so dropped it to an 8. So you get these little subtle tricks. If you get some really weird values, that's usually what happens. More often than not, you're going to get very clean numbers, numbers that have fractions that work real fast. Here you have x plus 4 quantity squared over 9, and then you have minus y plus 8 quantity squared over 4. Since I have a minus sign, it tells me I have a hyperbola. Also, since I have x squared first, you know that it's a hyperbola. X squared comes first. I'm sorry, since x squared comes first, the 9 is my a value, a squared, and it goes left and right. So we know that this one has to do this. My h and k will be at negative 4 and negative 8 for my center. My a squared is 9. My b squared is 4. My c squared is 9 plus 4, which is 13. So that gives you a value of plus or minus 3, a b value of plus or minus 2, and a c value of plus or minus the square root of 13. Now from here, I'll do this one more time. As we know that we're going left and right, my a value is the distance from the center to the vertex. Since it goes left and right, that means I'm adding it to the x value, or your h value here. So it's be negative 4 plus 3, comma negative 8, negative 4 minus 3, comma 8. You can simplify that if you want, write it as -1 or in -7. That's fine. I just wanted to write it out to show you that that's where things are getting moved to. Now, also remember, since the focus and the vertex go the same direction, it doesn't hurt to write it right away, so you don't forget that. And then -4 minus the square root of 13, comma, -8. And then your air quote co-vertices, or what was it, conjunctive axis? I forgot. It would be at -4 and then -8 plus 2, -4, -8 minus 2. Once again, if you wanted to simplify these two because you can, that's perfectly cool with me. I have no problem with that. It probably would be a little bit cleaner, but I just wanted to show you how that looks. So there's a couple quick examples. Remember, take your time when you're doing this. You should get clean numbers as you go through, aside from obviously your C value. Sometimes you get some weirdness here, but when you get into the actual values in here, when you're dividing out by what's on the right-hand side of the equation, going this way, you should get clean-ish fractions. You should have nothing left in the numerators as you go through. So hope all is well. If you got any questions, just shoot me an email. Thanks, guys. We'll see you later.